Alrighty, this is one of your bonus lessons. And so you can put it on whatever ISM page you want. We are going back to 313. So 313 part 1, that is where we converted rectangular coordinates to polar and vice versa. So basically this adds to it complex numbers, right? So all of our numbers are complex numbers, but we're throwing in the ones that actually have the imaginary parts in it, a plus bi. A and b would be constants. So a complex number can be understood as a point in the complex plane and can be determined by its corresponding rectangular or polar coordinates. So when the complex number has the rectangular coordinates AB, notice how that corresponds to this right here, it can be represented as a plus bi. So when we look at this right here, the complex number 3 plus 2i can be represented as this point in the rectangular coordinate system. So basically you're looking at like the x-axis is the real part of the number, and then your y-axis is the imaginary part of the number. Okay. All right, so earlier in these notes, and really multiple times so far, we have learned, or we know, that x equals r cosine theta, y equals r sine theta. Using these identities, so those are technically identities because that's just something that's always true for us, we can express a complex number in the polar coordinate system. So when we have r theta, which is what we know our polar coordinates look like, it can be expressed as r cosine theta plus I times r sine theta. All right, so here we go. Let's see what's going to happen here. Complex number is represented by a point in the complex plane. The complex number has the rectangular coordinates of -2, -2. What is one way, because there's multiple ways, but we're just going to come up with the easiest one. One way to express the complex number using polar coordinates, r theta. So in order to do that, we need to find r theta, or r and theta. So we are going to take our rectangular ordered pair here and convert it into rectangular. So to do that, remember, we know that x squared plus y squared equals r squared. So -2 squared plus -2 squared equals r squared. So it's going to give me 4 plus 4 equals r squared. So r squared equals 8, and r equals the square root of 8. And again, technically the plus or minus, but we can just deal with the positive one here if we want to. And square root of 8 is actually 2 square roots of 2, but we're fine leaving it like that. Okay, so then I need my angle. So we know that tangent theta is always y over x. So that's going to give me -2 over -2, which is a positive 1. So if I just look at this part, tangent theta equals 1, then I need to figure out what theta is. Okay, and in one little rotation here, tangent's positive first and third. So it could be pi fourths or 5 pi fourths. Right? So we need to come up with our actual r theta. Our r is square root of 8. But which theta do we want? When I look back up here, -2, -2 would put me in the third quadrant. This is my third quadrant angle, so I could rotate around and to the third quadrant and come out the square root of 8. So this would be 5 pi fourths. So there is my r theta, which is not what it's asking me for. It's asking me for my polar coordinates in that form. And then when I look back up here, I have got r theta, then I can express it like this. So I get r, which is the square root of 8, times the cosine of 5 pi fourths. Well, shoots. I feel like my board's doing weird things. 5 pi fourths plus I times r, well, shoots, r, which is the square root of 8, goodness gracious, times the sine of 5 pi fourths. So that is in that form. Now, I've reminded you multiple times, do not box or underline your answers. I am going to do it in this one though, because I'm going to keep going because I want to show you something. So like this is what I'm looking for. And we're only doing this because it's our notes. Otherwise, that's bad, real bad. And but look what happens if I simplify that. So if I simplify this, square root of 8 times the cosine of 5 pi fourths. All right, so that's in the third quadrant. So that's negative, so it'd be negative square root of 2 over 2 plus I times the square root of 8 times the sine, well, the sine of 5 pi fourths is also going to be negative square root of 2 over 2. So when I multiply those together, that's going to give me negative square root of 16 over 2 plus I times negative 16, square root of 16 over 2. Well, the square root of 16 is 4, divided by 2 is 2, so this is going to give me negative 2 minus 2i. So there's my imaginary number. Look back up here to take an imaginary number and put it into rectangular coordinates. That would give me negative 2, negative 2, and I'm right back where I started. That's why I wanted to stop here. But this number, this is the rectangular coordinates for the imaginary number. This is the imaginary number. These are the polar coordinates. These would not be on an FRQ. They would only be multiple choice. So you'd be able to find your answer, kind of how you wanted it there. All right, so let's say that we're going the other way. And a complex number is represented by a point in a complex plane. Using the polar coordinates, the complex number can be expressed as this. So basically, it's given us our answer from up there. Express the complex number using its rectangular coordinates. All right, so we're just going to work this out. We're going to have 4 times, so the cosine of 7 pi 6 is in the third quadrant, so it's going to be negative, and that's going to be negative square root of 3 over 2. Plus I times 4, sine is also going to be negative 1/2. Right? So that's going to give me negative 2 square root of 3, and then minus, because that's negative, so I'll just put that up there, I times 2, which really should be 2i, so it should be negative 2 square root of 3 minus 2i, like that's the proper way to write it. So that is my complex number, trig form of the complex number. Rectangular form is just going to be negative 2 square root of 3, negative 2, right? So it all just comes right back down to r cosine theta, r sine theta. And if you can remember that, what to do with these. And I would think if it's going to ask you to convert one way or the other, if there's a question like this, if you can see this in the question or this as an answer choice, then it's going to help you remember that, because they're going to have to give you something on that. It shouldn't be a crazy difficult question.